Here today in section 7.5, I want to talk about extrema of multivariable functions. So this is an analog to something we've seen in the past. It's basically the first derivative test for multivariable functions. Recall in the one variable scenario, if x equals c is a relative maximum or minimum of f, then f prime of c equals 0 or is undefined. So in the multivariable case, if the point AB is a relative maximum or minimum of the function f of xy, then either the partial derivative with respect to x of AB equals 0, and the partial derivative of f with respect to y of AB equals 0, or one of the two is undefined. With that in mind, let's take a look at an example. We want to find the critical points of f of x comma y equals 2x squared plus y squared plus 8x minus 6y plus 20. In order to do that, we first need to find the partial derivative with respect to x, which in this case isn't too hard. We end up with 4x, the y squared is a constant, so we get 0 there, plus 8, because the derivative of 8x with respect to x is just 8. And then we treat 6y and 20 like constants, so those don't play into anything. So the partial derivative with respect to x is 4x plus 8, and the partial derivative with respect to y is just 2y minus 6. And now we set these both equal to 0, and that tells us that x equals 2 and y equals 3. We set these both equal to 0, so that must mean that x equals negative 2 and y equals 3. So now we can plug x equals minus 2 and y equals 3 back into our function, and we get f of minus 2 comma 3 equals 2 times minus 2 squared plus 3 squared plus 8 times minus 2 minus 6 times 3 plus 20, and that works out to be 3. And so our critical point is the point minus 2, 3, 3. All right, let's take a look at one more example. We want to find the critical points of f of x comma y equals 1 minus x squared plus y squared to the 1/3 power. So like last time, the first thing we need to do is calculate fx. The derivative of 1 is 0, minus, and here we have to use the chain rule. We get 1 over 3 times x squared plus y squared to the minus 2/3 times 2x, which that simplifies down to be minus 2x over 3 times x squared plus y squared to the 2/3. And now we just need to find fy, which, just like above, the derivative of 1 is 0, minus, and now again we have to use the chain rule. So we get 1/3 times x squared plus y squared to the minus 2/3 times 2y. And that simplifies down to be minus 2y over 3 times x squared plus y squared to the 2/3. So now that we've found fx and fy, is there anywhere that makes one of them undefined or makes them both equal to 0? Well, in order for fx to be undefined, the denominator would have to be equal to 0. So 3 times x squared plus y squared to the 2/3 would be equal to 0, which means that x squared plus y squared would have to equal 0. So the point 0, 0 is going to be a critical point because fx is undefined at 0, 0. And similarly, 0, 0 makes fy undefined as well, because if we plug in 0 for x and 0 for y, then this denominator here is equal to 0, so fy is undefined there. Are there any points that make both of them equal to 0? Let's take a look here. If fx equals 0, then the numerator, minus 2x, would have to equal 0, but that can only happen at x equals 0. Okay? And here, if fy equals 0, then the numerator minus 2y would have to equal 0, but that can only happen if y equals 0. So the only point that could make them both equal to 0 is the point 0, 0, but like we've already said, that makes both of them undefined. So the only critical point we have is 0, 0. Now we just need to plug that back into the original function. So remember, f of xy is 1 minus x squared plus y squared to the 1/3. If we plug in 0 for x and 0 for y, then the output we get is just 1. And so that means the critical point that we have is 0, 0, 1.